Okay, cool. So, nice, my head is not interrupting and I have to be close to this. Okay. How many of you are familiar with distributed tracing? Yeah. Some of you, okay. I know some of you are actually doing this right now, or at least toying around with the idea. So, one thing I noticed over the last few months is that there's a lot of confusion on what is happening out there, what things you should care about, what distributed tracing actually is, and what things are in scope depending on what you want to do. And I think one of the places where there is usually some confusion is in everything that has to do with open tracing. How many of you have heard about open tracing? Many of you. Can any of you tell me what open tracing is?
A vendor-neutral API for tracing.
Yeah, that is basically what is on the website. And if you say it like that, it is exactly what it is. It's just an API. There is no implementation. There is no data format. There is nothing in open tracing other than just an API that defines, hey, this is a span, hey, this is a tracer, and when you have a span, these are the things that, like the operations that you could have in a span. Now, how many of you are familiar with the concept of a span in distributed tracing? Cool. A span is just an operation. Like you say, okay, I have operation X, it starts here, ends here. As simple as that. Then you could enrich this span with additional information. One of these types of information are tags that are key value pairs. And the other one, depending on the platform where you are, could be events, logs, or annotations. But it's basically a way of saying, okay, in this particular point of time, this thing happened. It could be a log line, it could be an event, a simple mark, depending on the API you're using, but that's it. Spans are just operation, key value pairs that say things, and events associated with this. Now, there are different tools that do this, that, the other, but this is pretty much it. When you have a distributed trace, it's basically a lot of spans that come from different services, because now we're no longer in the monolithic application world where there's one app that does everything. And you go to this app, it does whatever it has to do, gives you a response back, and everything is done. Now we have the awesome microservices, and everything is breaking down into layers and layers and layers of microservices. And when you want to resolve one thing to the outside world, you send one request, and then this maybe sends to two other services, and then these two others, and others, and others, and then all of this comes back. And you need to have a picture of what happened across this whole network of nodes that are interacting together to resolve this request. So then comes the need for distributed tracing now. Distributed tracing is just spans from all of these places put together in one big view that tells you what happened to resolve this request. No more than that. Spans, like the most important concept in tracing is the span and the relationship between spans. That's it. Now, open tracing is one of the tools that lately has been like most commented on regarding to tracing. And sometimes people tend to think that open tracing is the solution to the tracing problem. But then I would like people to understand a little bit of what is actually the scope of the tracing world. Now, I wanted to do this not in my words, but obviously my words, but I wanted to use material from the open tracing people, because I think they are giving a message, and somewhere in the process this gets corrupted, okay? And I have two slides here. These ones are from Ted Young from the Lightstep team, where he was trying to explain what is tracing. And there was this particular one here. Oh, sorry. There is this particular slide that was kind of controversial. And I think this can be used to actually explain what open tracing actually is. So when you're talking tracing, there are these 4 boxes here. One of them is your service, like this is the code that you control, your things that you type. And obviously if you want to trace them, you have to have a way to define, well, here's where our operation starts, this is where operation ends, please measure that. There are some other places that are not your service. It could be another service that you control or a service that somebody else is controlling that you will also participate on the trace. And you ideally want to have a way to correlate these things together. Correlate your part of this trace, or basically your spans, with spans that somebody else contributes to the trace. Now, there are the analysis systems at the bottom, which is like all this data has to go somewhere. You cannot take these pieces alone from each of these nodes and analyze them by themselves. You need to put all these pieces together somehow and then show you this little graph with all the spans that were used for a given request. And if you take these boxes and you start putting some names on them, you will get this thing here, where you will notice that open tracing is just this little box here. It is not a propagation format. When we talk about propagation format is, if I send a request from service A to service B, I need to have a correlation between that request there and that request here. So somehow I need to pass around some identifiers that will tell this other service, hey, my span ID here was ABC. And then when they create another span there, they say, okay, span DEF is a child span of ABC from this other system. And then that is what allows the reconstruction of the whole picture. Now, there's no standard way of sending these identifiers for correlation. Most of the people are using V3, that is basically the way Zipkin does, and we're going to talk about Zipkin in a bit. But there is no standard way of doing that. More so, there's an effort from the distributed tracing group on creating this thing called W3C trace context, which is a specification on how to propagate this data and how to make sure that when traces go across several systems, the correlation can be kept. And then if all these vendors manage to agree on something, then you would, like, this would be a problem solved. It would be no matter a thing of, are you compatible with Zipkin, or are you compatible with this, or with open tracing, or this or the other? No, it's, do you use trace context, yes or not? If you use it, you can correlate. But that is just correlation. Now, important thing is, open tracing is not a propagation, correlation format. So if you have a tracer A that is open tracing, if you have a tracer B that is also open tracing, it doesn't mean that they can talk to each other and correlate traces between the two. Even though people think that, yeah, this problem is solved, but actually it is not, because it's not in the scope of open tracing. So that's one of the things that usually people think, oh yeah, open tracing solves that. Well, no, it's not in the scope, and saying that two things are open tracing doesn't mean that they can cooperate on this. Then there's the other part at the bottom, which is, where do you send this data? You have all these spans, you need to send them somewhere so that you can analyze them, so you can investigate what is happening, generate topology and all sorts of information, metrics, whatever it is that you want to generate from that. And obviously, open tracing also doesn't do that. Open tracing is just like a facade that you have to create spans, but you have to have a proper implementation behind that that will manage everything that has to do with sending this data somewhere else. And this data is completely not defined by open tracing. It's defined by the implementers of the tracer. So sometimes people think, well, if I have open tracing, then I can send data to Zipkin, to Jagger, to this and the other. And it's sort of true, but not because of the reasons you think. There is no standardized format for tracing data. One of the things that was discussed yesterday on the workshop was, can we get to a standardized data exchange format for trace data? And there is some initial work on that, although now I would say 50% of the time on the workshop was spent on trace context. And I think that is going to become a real thing probably by the end of the year. But that's a really good step forward. And probably after that is done, data exchange protocol is going to emerge. But those things do not exist now, and obviously open tracing does not solve those issues. I guess, did anyone clear out any confusion at the moment? Yes, no? Like probably I said something and one of you thought, oh, I didn't know that, or I didn't think that it was that. Because that is what happens all the time when we talk about open tracing. Now, there's another presentation. This was by Ben Sickelman. This happened in February on the previous distributed tracing workshop, where he was talking a little bit about what exactly is the scope of open tracing. And I really wanted to use these slides because I think they're very clear with regards to what is the scope of this thing. Let me see, how can I maybe do this? No? Okay, good. So there's several places involved into this. Like this is kind of a different view of the very same diagram that I just showed from the other presentation. So there is business logic, there is instrumentation, there is the actual tracer that is taking this data somewhere else, the connection with the other tracing systems where this data is actually going to be stored, and then things that happen over there. And he took the time to say, well, what things are covered by which solutions. One of the most common tracing systems is Zipkin. Like Zipkin is everywhere. If somebody is doing distributed tracing, most likely they at least took a look at Zipkin because it has been out for quite a while. It has a very nice community, very open, very helpful, and it works very nicely. And even more so, there is a lot of high quality instrumentation written for Zipkin. In the particular case of the JVM, there is Brave, is the tracer for Zipkin, and it's a very nice piece of engineering, actually. I think you should go take a look at the code. It's a really nice thing. Now, the Zipkin ecosystem covers a lot of stuff. They cover context propagation, instrumenting libraries, actually having a data format to move this data, move these spans from your service into the backend system, which is also Zipkin, store it and display it. Like they close the whole cycle for distributed tracing. So if you want to do distributed tracing just with Zipkin, you can do the whole thing. Context propagation, everything. Everything is in the Zipkin ecosystem. Now, there are also the traditional APMs. You can think about New Relic, Dynatrace, AppDynamics, all these people, and they also have a lot of places where they hook, but all of this is basically hidden from you. You cannot come and say, okay, I want to have a say on how you instrumented this. No. It's just you put some agent, they do some bytecode instrumentation, and then boom, data starts showing up on their front end. So this is like the one in which you have the least control of the things. Then comes the trace context spec. It has nothing to do with spans, has nothing to do with format, like same as we discussed before. It's only concerned with this little thing on the top, correlation between different systems. So how do you connect this with that is happening over there? Then comes X-Ray. X-Ray is Amazon's distributed tracing product. It was released, I think, over a year ago, and it's kind of catching up. A lot of people are using it, and it's again similar to the Zipkin ecosystem. Like, it's the whole thing is instrumentation, data format, exposition format, UI, analytic APIs, everything on top of the tracing data, but this is a commercial product. So open tracing, nothing to do here. Your code, well, you could interact with the SDK to add certain tags or to create some particular spans, but this is a complete different ecosystem that has nothing to do with Zipkin, with trace context. It has nothing to do with anything else. Then Open Census. How many of you heard about Open Census before? So it turns out that after many years of working on tracing internally in Google, they decided to open source the way they do tracing internally. And all this effort turned into Open Census. Open Census is a library for metrics and tracing. It's not only distributed tracing. They have, well, they call it stats, but they cover context propagation, they cover metrics collection, and they cover distributed tracing. Now, they do have a way of propagating context across processes. They do have APIs for recording metrics and traces if you want to do it yourself. And they have a pluggable exporter systems. So they are not tied for you to use Stackdriver for tracing. No, you have the API, you can set up your traces, do some manual instrumentation on your app so that you say, okay, span starts here, ends there, blah, blah, blah. And then you plug the exporter where you decide where do you want to send this data to. Currently, you can set it to Stackdriver, you could send it to Zipkin, and I think Instana is also getting an exporter for Open Census. So on the metric side, they have Prometheus. I think they also have Signal FX was the other. They have quite a few implementations. So this is also whole package up to the exporting data, but they are not tied to one specific analytics and visualization backend. So it could be Stackdriver, but it could also be Amazon X-Ray, could be Camino, could be basically anything that you want. And then again comes Open Tracing, which, just to reinforce the idea, has no saying on context, on export, on instrumentation, like automatic instrumentation for these things. It doesn't have any saying on how you store, visualize, or analyze this data. It's just an API. It tells you how to model a span. And I hope that this information helps clarify what it is. And when you guys go somewhere else and somebody asks you, hey, do you know about open tracing? You will be able to share a much accurate version of what it is. Because every time I ask someone about open tracing, they have a weird idea of what it is, what it actually means, what's the actual scope. And I hope today we kind of clarify that part. Now, closing that side, let's get into where Kamon sits in the world of distributed tracing. Now, Kamon is a library that I have been working on for the last, actually, I have a slide for that. It's a library I have been working on for almost 5 years. I think in May is our 5th anniversary. It's obviously open source, free. You can use it, you can extend it. Guys at Emnify are using Kamon for quite some time already. And it has been initially focused on the Scala ecosystem. So this all started because we had some Akka services that we needed to monitor. We were putting things in production, and we were not able to do that. There was no tool out there that could help. Back then, there was the TypeSafe console. I don't know if you heard about it or tried it before. It wasn't in our budget and it wasn't useful for what we wanted to do. So we said, okay, let's do something ourselves. Then we realized a lot of people were having the same problem that we were having. And we decided to share this with the community, give a little bit back. And then, well, we liked the process and we started improving until we got to releasing 1.0 in January this year. It's the first Kamon version that has distributed tracing. Actually, it should probably have been called Kamon 2.0 because the previous one was heavily used in production. It could probably have been 1.0 already and this be 2.0, but anyways, now there is a stable release that people are using in production. And I say vendor neutral because that's like the new thing, like everything is vendor neutral, next generation, something, blah, blah, blah. We're not vendor neutral. We have an opinion on how metric collection and tracing should be. And we package this opinion in Kamon. And some people might want it, some people might like it, some people might want to just take some other option, but we are really eager to help people who have interest on proper latency distribution of requests. We believe context propagation has to be done in a certain way, and any backend or reporting backend, as we call them, that supports that is good for us. We love Prometheus from the open source side. We love Zipkin, and we're super happy to help people use them. And we discourage people from using things like Graphite, StatsD, like sending things over UDP, like sending stats that can alert you if something is wrong with your system over UDP. That seems like something you shouldn't be doing. Like we advise people against doing those things. So vendor neutral because you can integrate it with anything, but we do have an opinion on how things should be done. And when we're doing distributed tracing, there's one problem which I think is the biggest problem of all, which is context propagation. Like, it's not about how to model a span. Like Zipkin did it. The Dapper paper in which everything is based was clearly describing how to do that. And all implementations I mentioned today, like Zipkin, Jagger, well, I didn't mention Jagger yet, but Zipkin, Jagger, OpenCensus, OpenTracing, all of them, even Kamon, they have a very similar notion of what a span is. Defining a span is not the problem. The real problem is propagating context. What happens when you cross a service boundary? And in the particular case of Akka, Scala, and all these async frameworks, is how do you propagate context when you go in the same JVM across threads? That becomes a major challenge. Like there was this on the left, this traditional model, traditional way of doing things when you're using servlets, in which there is one thread per request. You take a thread, it will do everything as blocking operations within the same thread until the response for this request is ready. And there might be cases in which you submit some tasks to an execution context and then executor service in Java. And then you get a response back, but these points are very well defined. And you could manually propagate context to this other thread so that there is some correlation between the thread that is tied to the request and the other ones that might collaborate on this. But then when you start using Scala and you start putting futures all around, or you start using actors, then it's like having a distributed system within the JVM. Things just jump around here and there. Like if you have a future and you do future and then you map, flat map, blah, blah, blah. All of these little pieces of transformation are going to happen on different threads that you cannot control. It's just going to be thrown to the execution context, and wherever it gets to run, it runs. And then how do you propagate context there? More importantly, how do you propagate context in applications that are already written? Because you could say, well, you manually take some context and pass it around with method invocations, or you pass it around with you send a message to an actor, so you make it part of the protocol. But you don't need that unless you're getting into monitoring. Like if you're monitoring, you want to know when a request starts and when a request ends, so that you can measure the latency and have an alert on that. But if I tell you, hey, you know what, now you have to change all your actors, because I want you to include one particular thing on every message so that you can do monitoring on software that is already running in production. It just doesn't happen. Okay, we tried hard to make everything compile time and blah, blah, but it's just not possible. I mean, it's not possible, no, it's not practical to do it. Once you have a code base that is already running, and typically people don't do monitoring upfront. Like, you see this t-shirt that Sebastian has, do you even monitor? Like, it's insane the amount of people that we meet and we ask them, how did you do monitoring? And they are like, well, we don't. It's like somebody tells the logs, and if they see some errors, then they go and see, or somebody calls a customer, said, hey, you know what? Your service is very slow, or your service is not working, and then they go and SSH to a server to see what is happening, and then maybe they bounce a process or something, and people are not doing monitoring until it happens that they crashed, and they couldn't know why.
It doesn't need to,
Sorry?
absolutely need to be like that, but it should be that it gets deprioritized, so that you build a feature, get it live, and you split it into what has the most business value, and then there is monitoring afterwards. And by the time you have built the feature without monitoring, it's then hard to integrate the monitoring part, even if it comes shortly afterwards.
Those things happen. I'm not saying that people are like deliberately saying, oh no, I don't want to do monitoring. No, it's just the rush of the day. You have to ship features. Your customers want you to solve this problem, solve that, solve the other. And then suddenly you went from one customer to 20, and now your system is reaching its limits, but you don't even know what the limits are. So at this point, you need a solution to get metrics, to get tracing, to understand what is happening with a minimum effort. And that's why we created Kamon. That was our main idea. Well, okay, there are all these really hard problems that usually get solved by paying some API and vendor a lot of money. So, well, why don't we solve this problem, and we share this, and we created a library. And by the way, this thing at the bottom is because of the name. Like at the beginning, it was called the thing for monitoring Akka. And then that works until you want to create a GitHub repo, and you don't know you don't know what name to use. And like it took us, I think, 2 days to decide on a name so that we could create a repo. And then I told Diego, you know what, let's Akka monitoring, come on, yeah, let's take just this, and then later we will change it. With time we grew some love for it, so now the name is just Kamon. Now, what Kamon looks like. Kamon is a library that has metrics, context, and tracing, okay? But additionally, it has automatic instrumentation. That is the part where it differs from many other open source tools. Like many other tools are just the library, so you can manually record things if you want. But in the particular case of the Scala ecosystem, that is not enough. Like you will need to do many more modifications to your code to actually get context propagation and get value out of your monitoring data. So we decided to, okay, let's use AspectJ. Let's put some instrumentation on the Akka code, on the Scala code. Let's do this and get metrics and things out of this. So your service will interact with the Kamon APIs. Most of the time, you will not even write any code related to Kamon, because the instrumentation will, like the automatic instrumentation we ship, uses the metrics and tracing and context APIs to do things, but it does it automatically. So when you need to interact, it's because you want to change the way something is done automatically, or you want to add some custom metrics, or you want to add some custom spans. But the most common case is you don't deal with this. You just let it do the thing it does automatically, and then maybe you improve it. And then all this information in Kamon gets then sent to reporter modules that can export this data somewhere else. For metrics, there is Prometheus. Well, JMX is actually from the previous version, but there's now Prometheus, Datadog, InfluxDB, Sematext. For the tracing part, there is Zipkin, Jagger, and Camino, which is the startup I'm working on, a startup related to monitoring. And that's it. Now, let's look at the metrics API. The metrics API is kind of simple. It has a dimensional data model, different to, for example, things like Graphite, where there's this like scoping of metrics, and there is only just one big name where you define the metric name and then the values. We have the same model that Prometheus has, for example. It's a metric name and then key value pairs, usually called tags. We call it tags, that give you different dimensions to a particular values for different dimensions on the metrics that you're recording. So if you're recording operations, okay, like the, if you're recording actor metrics, you have a metric called Akka, actor processing time, and then there is a dimension called actor that will have different, no, actually it's called path, where there are different values depending on the path of the actual actor that you are recording. If you're familiar with Prometheus, this is basically the same model. All the data that we have gets flushed to the reporting system on a specific interval. Like by default, I think it's every 60 seconds. We collect everything and we send a message to the reporter saying, this is what happened in the last minute. To record things, we have these 4 instruments, the counters, gauges, and histograms. That's kind of basic. And there's the range sampler that we're going to see now what this thing is about. We use the HDR histogram underneath that allows us to have highly detailed data on latency, on anything that is a distribution. So the histograms and the range samplers have this thing underneath that allows us to keep all the latency measurements that happen up to 1% precision by default. It could be more, but we use it by default at 1%. It means that if you record 100 milliseconds in a histogram, it will not record exactly 100 milliseconds. It will do a small adjustment to get on the right bucket, but this bucket is no longer than 1% away from the value that you are recording. And now, once this is done, all measurements get to the right bucket and all measurements get reported to the backend. So if you have Prometheus and you made 1 million requests, you have 1 million values in some of the buckets that you report. If you do the same with Camino, you will get the whole detailed data to Camino. If you have something else like, I don't know, InfluxDB, they don't support distributions. If you have that, then you make a summary out of this, and then the summary is what gets sent to the backend. And that has a problem because we love distributions and percentiles. Why? We live in a world where there is no longer one server handling everything. There was a time when a service was one beefy machine where you run everything. Now, when you have distributed systems, latency is spread across nodes. It's no longer the one node, but 10 nodes that represent one application. And if you want to do monitoring, you should monitor latency in terms of percentiles, but you cannot get percentiles out of summaries that you get from 10 nodes. Like if you have the 99th percentile on each node individually, you cannot aggregate this data in any way. Average of that is a lie. There's just no there's no mathematical way of getting a percentile out of other percentiles. You need the raw data so that you can properly aggregate, you can properly see the percentile, and then see, am I under my SLA or not? So we highly encourage people to use platforms where you can properly aggregate data. That's one of the reasons why we love to use Prometheus, or to encourage people to use Prometheus, because that is the only open source tool we see that can help you do the right thing. Okay, you need to tweak it, you need to do things here and there, but it's the best possible job you can get if you don't want to pay for a solution. So that's a cool thing there. And there's this thing called range sampler. I think counters, gauges, and histograms are pretty simple for people to understand, but we created this thing specifically for the case of Akka. Because when you're monitoring a mailbox, this thing is always going up and down, up and down, up and down, up and down. And if I tell you the mailbox size is 5, what does it mean to you? Like during the whole minute, it was 5. You don't know, like, was it 5 all the time? Was it in 0 ever? Did it go up to 1,000,000? You just don't know. 5 could be 5 on the way up, 5 on the way down. 5 in who knows what condition. Could be having 5 all the time and just didn't move anywhere. And you cannot know with just a single point in time. Sorry, a single point for the whole minute. Now, we were thinking, okay, how do we do this? How do we do this? And we came up with this idea of trying to track the behavior of the mailbox instead of one particular data point for the mailbox. So we have this thing called range sampler that works with variables that start at 0 and can go up and down. So this thing internally is tracking the minimum, the maximum, and the current value of a queue, and is constantly sampling these things, like getting these values and storing them in a histogram. So if you take this data and you make a heat map like this one that we have here over time, then you can see that here maybe the average mailbox size could have been 5, but you notice that at some points it goes below 5, at some points it goes below 10, and you can notice that most of the time it is operating somewhere between 5 and 10. So this tells you a lot more information of what is happening here than just a single number. Like if you are, for example, using Prometheus and you need to graph this, well, try to graph the minimum and maximum value so you have an idea of what boundaries these things moves in. Now, this also tells you more things, because if it's most of the time around 5, but you see that the minimum keeps going up and up and up, well, maybe the actor where you're sending these messages to is not able to catch up, is never getting this thing down to 0. Now, if you see high spikes, but you still see that it goes down to 0, then the throughput is increasing, but it is still able to handle it because the minimum went again all the way back up, all the way back down. So there's a lot more information on the behavior of this variable that you're monitoring than if you were just getting one single data point. And this is something that, as far as I know, only we are doing. When I presented this on the workshop a couple of days ago, there were a lot of questions related to this because it's like a different concept, and feedback was pretty nice. So if you have any ideas on how this could be improved, or you have more questions about it, just let me know. Now, sorry, there was one thing that I forgot to mention here. If you want to export your data to something that we don't support at the moment, you just have to implement this interface here. And it's basically this method, the one that is important. So every minute you will get an object with all the metrics information, and you somehow translate that into JMX or into statsd format or into whatever format it is, and send it outside. That's all you have to do. And then adding a report, this is Kamon.add_reporter. Here's the instance, and Kamon will take care of taking this instance and constantly calling it. It will create a thread where this thing is executing on the side so it doesn't block your main threads, blah, 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 blah. So adding new exporters is kind of simple task to do. The tracing API, which is the important thing we have to do here, it's heavily influenced by Brave. Brave is the Zipkin tracer, and open tracing. Actually, when we decided to go into the distributed tracing world, first thing we did, well, there's this thing called open tracing. Let's get into that. And we started coding distributed tracing into Kamon as an open tracing tracer. But then there were certain points in which we started feeling like the open tracing interface wasn't going in a way in which we believe is like the right way of doing it. And we took out open tracing from Kamon, but many ideas stayed. For example, the tags convention that we use, we just follow the semantic conventions from open tracing. There is the concept of span and span context. We do have the same. Now, there are also some differences. One important difference between us and others is we believe that when you do tracing, you should have metrics for that as well. So many systems have the metrics based on sample data. We believe that you shouldn't do that. You should have metrics out of every single invocation of an operation that you are monitoring, because there are ways of doing this. Now, if you sample, you might be missing outliers, you might be missing errors, you might be missing situations that would require you to take action, or that maybe happen more often than you think, but you don't know it because you're sampling and data just gets thrown away. So even if you have to do that, because tracing has a lot more overhead than metrics, you should still keep metrics that correspond to the tracing data and can tell you exactly how this thing is behaving. So you have some samples of how this thing went on the distributed tracing world, but you have the entire distribution, latency distribution of how this thing behaved. So our span API has a little bit of additions so that you can control how tracing, how metrics for this particular span work. Also, open tracing has the concept of baggage. That is like a little bit of context that you can pass around, but we believe that context propagation is a problem of its own. It's not something that you kind of build on top of the tracer API. So that was when we decided to break this connection with open tracing. It was like, we don't want to do it this way. Let's separate the context propagation API and let the tracer use context propagation for operating, but let's separate this and have context propagation as a separate concern in Kamon. Also, if you want to create a new exporter for traces, same thing, simple interface to implement. Kamon gathers all these spans. Every certain amount of time, it calls this method where you take these spans, transform it, send it to Zipkin, to X-Ray, to Camino, to whatever it is that you want to send it. This is a little bit of how the span API looks like. So you have a span, and you can add tags with strings, numbers, and booleans. You can add marks. That marks are this concept of events within a span. So you will notice that tags are just a key value pair, but a mark has a timestamp. If you do this mark message.dequeued, for example, internally it takes the current timestamp and adds it as a little event on the span, or you can provide your own time for this event. And of course, the tag metric enable and disable metrics APIs that allow you to control whether you will record metrics for this particular span or not. Once you finish the span, metrics get recorded, the span gets flushed to the tracing system in case it was sampled, and the story is over. Then comes the context API, which is a completely different thing from what other libraries are other libraries, like open tracing is doing, which is like we have this context that is basically a key value pair, but the keys carry additional information about what this context is. What's the type of the value there, what is the name that you are assigning to this key, and whether this should be propagated in process only, or if this should also cross the JVM boundaries. So the most common case of propagation across JVMs would be HTTP. You make an HTTP request from microservice A to microservice B, and then you need to propagate somehow context. And this context usually contains tracing data, like what is the span over there so that I can correlate on the other side. But sometimes it could contain a user ID. It could contain, I don't know, the request ID if you are running on some platform that gives you a header with a request ID and you want to carry this thing around, or language in which the user wants to operate, so you can have proper error messages if you need to do something on the other side. Like, there are pieces of context that are not directly related to the business logic of the first entry point of this request that you might want to carry around. We usually encourage people to use this for operational data, like tracing, maybe some dimensions that you could use for metrics and that kind of thing. You could transmit business-related data as well, but I think, like, even though it's possible, if something is business-related, maybe you want to keep it within your code base, and something is operations-related, you can keep it in the context. Also, there is a binary propagation. If you're doing Akka, you have a cluster, they communicate with each other, and there's a binary encoding that puts the context into the message that goes to the other nodes and gets unpacked on the other side, so you get transparent context propagation when going across nodes in the Akka cluster. And these codecs are pluggable. That's a very interesting thing. Because you get to decide at runtime how you want to encode these things, and we're going to see an example of what we can achieve with that.
So does this happen right before serialization?
Sorry?
Does this happen right before serialization?
Mm-hmm. Yeah. When there is an envelope message that goes to the remote actor system, and the instrumentation hooks into this, take the current context, serializes it and puts it in there, and then on the other side it will deserialize it and set it as the current context, and then it keeps propagating. Now, precisely because of that, there comes the concept of the current context. That's one important topic when talking about propagation of things. So at every single time there is one current context, like the context of the operation that is currently executing on this thread. And the way we handle this is we have a context storage thing in Kamon where you say, okay, make this context the current context. And you do some work that is related to this operation. So it could read things from the context. It could put things on the context. It could do whatever it was with the context. And then when you are done, you just close this scope. So these contexts are set effectively in a thread local for a brief amount of time and then take out. So when you are processing actor messages, for example, each message has its own context. So it comes, puts the context, does some processing, takes it out. Okay? Most of the time you will not have to deal with this yourself unless you have some corner cases that you need to fix, like the guys had to do that today. But most of the time you don't need to deal with this kind of things. But it's important to understand that there is a place where the context is actually stored for a small period of time, and then it's taken away from there. A cool feature about the context is this codex. So you can decide from configuration, like you can configure Kamon to serialize the context in very specific ways. Like you can say, well, when you go binary from here to the other node, don't do what you usually do this other thing. So, or you say, well, you know what, I have this, my own object that I want to propagate to the other side. And you have to tell Kamon how to do that. So you say, okay, for my custom thing that I want to propagate, use this codec here. And then Kamon will just use that, pack it with everything else that Kamon will usually pack to go to the other side. Unpack it on the other side, and that's like transparent for you. You just put configuration, put something on the context, and you're good to go. Implementing codecs is kind of simple. You have just encode and decode, text maps for HTTP headers, and byte buffers for binary data. The text map is basically like a small abstraction It's similar to a map. You can put, get, and get all the values from the text map. That's also something that is like a leftover from the open tracing days, and I think we're gonna clean that out a little bit. But this enables us to do a couple things. How many of you are familiar with the tracing in sidecars, like Envoy, Linkerd, sorry?
The Kubernetes area.
Yeah. Those things are now becoming a lot more popular. Maybe in the Valley, obviously, a lot more than everywhere else. But there is one little note when people say, oh yeah, you can just put Envoy here, and then suddenly you get distributed tracing solved. Well, yes, but there is a little line there that says, for that to happen, you have to propagate these headers when something comes in and when something goes out. And then if you're running Akka, Scala, or anything else, like your code needs to somehow propagate these headers that came with the request with any other request that you do downstream. So it's kind of really cool feature to have, but it's not magical. You need to do some work for that to happen. But since the way we created Kamon has a concept of string keys that is basically like context tags, you can decide how to encode some of these things when you go to HTTP headers. So these headers here are headers for Linkerd. So if you wanted to get header propagation within your application and you are using Linkerd, you just add this configuration and Kamon will automatically propagate this context from the entrance to your service to the exit on the other side. You will not have to modify any code if the instrumentation is able to take the context from one side to the other. So you just say, okay, there's a key called, I don't know, L5D context trace. It's called like this. So it will take this header name, put it in the context, and then on the other side, read this from the context and put it on the header name. Boom. Now you have sort of magical distributed tracing without having to modify your code. But that's not something you would get without particular instrumentation on your side. And the other interesting thing that was discussed this week is currently we use the same format for trace correlation as Zipking. It's called B3. And it has a set of headers that say, okay, this is the trace ID, this is the parent ID, this is the span ID, and so on. And the trace context format is different. It has a trace state and a trace parent headers that have a different format. And then you might want to switch into this format once it becomes standard. And we wanted to allow these things to happen without having to re-codify everything in Kamon. And since the context for the span is also pluggable, you could just compile this library. We did an implementation of the trace context spec as it is now. It's going to change, but anyways, if you compile this library and you have it in your class path, you just add this configuration, and suddenly you are now using trace context instead of using V3. Again, just with configuration, which seems like a pretty nice thing to have in terms of context propagation. This is the instrumentation we have available at the moment, Akka, Scala, blah, blah, blah. As you can see, there is mostly Scala ecosystem, not much outside of the Scala world. These are all the reporters that we have at the moment, and we want to have a reporter for Stackdriver and for Amazon CloudWatch and X-Ray. And this is what we want to do in the next months to come. First, standardized HTTP instrumentation. Like we got into enough HTTP instrumentations written by hand where we copy paste things like what we did for Play, we copy paste and we put it in HTTP4S, and then we copy paste and put it in Akka HTTP. I think we kind of have an idea of what we want to achieve with HTTP tracing at least, so we can make sure that every single framework that is instrumented with Kamon will work the same. Like if the play module gives you this tag, and this tag, and then you instrument another application with Akka HTTP, you will get exactly the same thing, the same features, the same behavior, same tags for metrics. Like get a consistent experience across all the instrumentations. Improve a little bit startup and configuration. Like it works, but I think the reporters can get a little bit more love with regards to how to set them up, how to start them, how to stop them. Formalize context tags. That's just basically making, in general, the API better. And micro benchmarks and continuous performance monitoring. Like we constantly test when we do big changes, but this is not something that is automated in any way. It's not something that we are officially tracking somewhere. And it's kind of disappointing that a performance monitoring library doesn't have benchmarks that tell you, well, this is how much this is supposed to cost you in terms of performance to trace or to have an actor or, yeah.
So how much does it actually roughly cost?
Well, it depends. Last time we were testing, for example, creating a span, adding a couple tags and finish it, I think it was around 400 nanoseconds to do this operation, but it will depend on how many tags you put, because the more tags you put, the more work needs to be done after you flush this information and when you do metrics about it. Recording a value on the histogram takes about 4 to 5 nanoseconds. So actually calling system.nanotime to get the timestamp and then get another one is more expensive than actually storing this on the histogram. That was one of the reasons why we decided to go with the HDR histogram. Like it is not made for this kind of situation, but it's a super efficient data structure, and we had to like work quite hard to make it fit the use case that we have. But once we got it done, it's the most performant thing that you can find to store latency. Like there is nothing else on the JVM that can beat this. And if you find one, let me know. But for now, that is a beautiful piece of engineering that just beats everything else. And more reporters, yes, of course, and nicer out-of-the-box experience. Like one thing we notice is that it's sometimes complicated to set up Kamon. Like if I come to help you, I already know, well, you need this library, you need this, you need the other, blah, blah, blah. You need to add this configuration here, you add this there. And 5 minutes later, you're monitoring. But if you come to the website and you start trying to browse the documentation and try to figure out what you need to do, you will probably end up going to the Gitter channel and asking for help. And that shouldn't be like that. It should be simpler. It should be like you don't actually need to modify your code. You just need to figure out what libraries to use, what to put on your configuration. And yeah, you need to add one line to start the reporter. But you need to add dependencies to your app. And sometimes you're not clear which ones you should be adding. Like, oh, I need to have the trace IDs on the logs. How do I do that? Oh, you just need the Kamon lockback module for that. Oh, I didn't know that exists. And what do you need for this, for that? Like, it's usually a kind of a struggle to get it working. But once you get it, then everything is fine. So we want to improve this. We want to make it better out of the box, like simpler setup, simpler configurations, having simpler defaults. Like it could happen that if you're monitoring Akka, you're just going to say, I monitor every single actor, and that usually breaks things. So we should have more sensible default configuration so that when you just put this thing, it works on a decent way. And I think we can do that. So we should focus on get it right. And after we finish that, we will get rid of Aspect J, finally. We have been working on a new agent for instrumentation. It's based on ByteBuddy and some ASM tools. Diego, how can we say, co-author in Kamon. Like we have been working together on this since the very beginning. He's heavily invested on this new instrumentation agent that will take AspectJ away, and we will have our own agent. And our goal is to make Kamon a more APM-like experience. Like currently, if you are using, I don't know, New Relic, you just start your app with this Java agent, and everything just gets monitored somehow. Like, and we could provide that experience, and it could be a lot simpler for people to start using this. You just say, hey, people, just add this to your app and start working. So if we get a much more decent default behavior, and we pack all our instrumentation in just this agent, then it will be a lot simpler for people to just start using this and still keep the ability to use the APIs if you want to do these things manually. If you manually want to create spans or metrics or context or whatever it is that you want to do. So if things go the way we want it to be, it's going to be a lot simpler to add Kamon to applications, and then we can expand even further, like get into this Java world again, like get Spring instrumentation and all these other things that people are using on the JVM, but outside of the Scala ecosystem. We wrote a little bit about this on our blog, so there's a bit of more of description of what we want to do and why we want to do it. So if you want to read, that thing is up, and that is it.
Is there something you should keep in mind if you now create custom metrics when you switch from AspectJ to Canada?
No, because the Kamon APIs will stay the same. The only thing that is going to change is how we apply the automatic instrumentation. So currently you have to start with the AspectJ agent, and you need to add 10 Kamon libraries to your build, and then you need to add something on the configuration file for this to work. So instead of all of this, let's say that we have a pre-packaged Prometheus exporter. So you just add this thing, and it will start Kamon, it will start Prometheus exporter, it will measure all your actors, all your requests, everything, and you will just be happy and saying, oh, Kamon is awesome. Any questions, any comments, any ideas?
I've seen a couple of times that other metrics library use annotations to, well, instrument that code and to, well, collect invocation numbers and latencies for a certain function. Is that something that you are planning, or something that you don't like?
It's something that we have. Where is it? Here. The previous Kamon version had the annotations so that you could, where is it? Add metrics and traces and stuff just by doing annotations like segment. Segment was the old concept that is now a span. So you could just add an annotation and say, measure this, count the latency of this particular invocation, and so on. So this is something that we have for the previous version of Kamon, and it's something that we will upgrade for Kamon 1.0 as well. So it's just a matter of time for this to be upgraded. The base is there, so I don't think it will be a complicated thing to do. It's just a matter of time. But I think this can be a very simple way of adding things, especially for Java people. I think Java people are much more eager to use annotations. In the Scala world, it's not that common. I think that's why we didn't get that much into this. But like what we need to do things is to people to ask for them. Like if someone starts nagging, like, hey, what happened with the annotations? What happened with the annotations? We will do it. But we created some modules before, like this. There's this Riemann thing, FluentD. Nobody's using that. Like somebody contributed it, which is really cool. They did it, they share it. But we were maintaining those things, and like there were very, very, very few downloads for those modules. So if nobody comes and asks for something, we're not going to upgrade it. Okay, I prefer us to grow on the instrumentation side. Like annotations is something that definitely we should get into, rather than growing on reporters that people are not using, just because they were before. So if we do annotations, we benefit a bunch of people. If we do the Riemann reporter, we benefit 10. And this is something we do on our free time. So we can also like say we just don't want to do it. It's open source. People can do it themselves if they want. Anything else?
So could you show an actual trace?
Oh, yes. Well, here we have some in the documentation. There's in the Zipkin reporter, I think we have, let me see. So, how do I do this thing? Open image in new tab. This is much better. So this is what a trace looks like. Is each of these blue things are actually spans. We say, okay, this operation started here, finished there, and each span has a bunch of information. So obviously, when did it start? When did it end? There are the tags that are these key value pairs. In the particular case of Kamon tracing and Akka application, you have this like component, what the actor system was, where was the path where the actor was created, and this little thing here are these like events that we have within the span. So even though there is a start and end time, there is also this thing that says, okay, from the beginning of the span, 267 microseconds passed, and then the message was dequeued. So in the particular case of Akka, the span represents from the moment in which a message was put on the mailbox until the message was processed. But a part of this time is going to be spent on the mailbox, like just waiting to be processed. So this mark tells you when this was actually dequeued, so that it starts processing and then finishes processing. I think this was a light bulb moment for you, Stefan.
Yes. I thought I saw some white space on the time axis between different actors. So I actually thought like that this white space is actually time in mailbox of that code.
No.
Span. Okay, I didn't know that it's processing time plus time in mailbox.
Yeah, it is. It is. There is also Camino, which is the tool. Well, these screenshots here are kind of old, but I think here there was a more interesting trace where you have all these spans, and you can see these remote messages. If you have JDBC, there is a JDBC module for Kamon that can actually create a span with the query that goes to the database. So if you see that, oh, there's a lot of time being spent here, then you can see, oh, okay, this is the query for searching products that takes a fuck ton of time to run and all that kind of stuff. So I should have prepared more visualizations of this. But if you need anything, like I can also show you like live Camino thing from how we run this thing. But I didn't want to like be pitching or tool, rather be talking about open source and tracing in general.
Yeah, somewhat dumb question. So how far can you take the distributed tracing then? Because as I understood in the very beginning, it's really also meant to trace transactions which go between completely different systems, right?
Sorry, can you repeat?
So how far can you take the distributed tracing? So like we now we're using the Kamon to trace in our Akka cluster, okay, that's fine. But I don't know, just a dumb question, does it also make sense to take it beyond that? Would you, for example, also extend the tracing to our MySQL database? Does these things exist?
If it was possible, yes.
So meaning I have a tracer running on the MySQL, and it will even tell me then what happened on that side in the end.
Yeah, if it was possible, as far as I know, there is no instrumentation on MySQL itself that can tell you, okay, I spent this time scanning indexes and this time doing this and this time doing that. But if there was, it would totally be useful to have that information in your tracing system. Because every time you see a big span that represents most of the latency in an operation, you want to drill down as much as possible to see what is the reason for this thing to happen. Like, one of the things that the guys at Google and Amazon are working on is integrating your tracing system with their tracing system. And that's one of the reasons why the trace context specification is being worked on by all of these vendors together. Like, they compete with each other, but they are all sitting together on the same table to talk about this, because the idea is you have your trace, then suddenly you use the Amazon SDK to call some Amazon service, and then this calls something else, and then this maybe goes to another cloud provider where something else happens. And you want to be able to correlate all of this. Your part, the part that corresponds to Amazon, the part that corresponds to whatever was there afterwards. And you need a way to correlate all these things, and the trace context spec is supposedly going to allow you to do that. So if they are going to these lengths to allow you to trace what happens inside of their system, like allow you to correlate these two things together, well, why not do it with other things that are not from your cloud provider? I think Cassandra, for example, has tracing, but I don't know if there is a way to correlate our traces with the Cassandra tracing. And that's something that we have on our roadmap. Like, we want to sit down and see, well, we know Cassandra has tracing, we know we have tracing here. Can we connect these two things together so that when we have a long Cassandra query, we can understand why did this happen? When we do Kafka instrumentation, we're most likely going to add some internal spans for Kafka as well. If we find it, like, I cannot say for sure because we need to evaluate it first, but if there is anything useful inside Kafka to have a span for, we should definitely do it. Yep.
You told us that you use a binary protocol for context propagation in Akka World. When I have a lot of microservices, independent microservices, with its own Akka cluster, and you release a new Kamon version, do I have to upgrade all the microservices in one step?
Well, it depends. Currently, like, this particular codec that we have for the span information, we don't change it. We don't touch it. Okay? So we know the data model that we have in Kamon for tracing, and we don't want to touch that anymore because we want to avoid these situations. What is important is that all nodes have to have Kamon. Otherwise, the context will be lost. And we change the instrumentation so that if there is no Kamon on the other side, it will not break. Like, the messages will still go to the other side, but you will lose the context. Yeah, before I think it will just fail. Now it will pass but lose the context.
And another question, the automatic instrumentation is very good, but when there is Akka 2.7, 2.8, 2.9, you have to tune.
Yeah, we suffer that.
Yes,
With Akka, not that much. With Play, it's quite a thing. Okay. Like, Play.
The
Play.
same problem is in the Lagom framework. They have to wait. Yeah, Akka comes with a new version. Play comes with a new version, and Akka Lagom is on top of this framework.
Yeah.
You have to wait.
Yeah, every time there is a new Akka version, we have to release. And I don't know if you notice, we have support since Akka 2.2, and currently we are supporting 2.4 and 2.5. I think we also released for 2.3. And for Play, we have Play 2.4, 2.5, 2.6, and all of them are slightly different in different and annoying ways. but we are the ones in charge of solving that problem. So basically, when there's a new version, you start nagging on Gitter. When are you going to upgrade to play 2.7? My service is not working. I want to upgrade now, and I cannot because of you. So we go. But I mean, you do it nicely, and we will do it.
So the effect would be that, like, the instrumentation to add this context would, for example, fail when a message is sent, so that we get an exception probably or so.
No, currently,
What would be the effect of such incompatibility?
well, in the case of Akka, if a message goes to the other side, since the Akka envelope itself is built with protobuffers, what will happen is like you have an extra field there that they don't understand on the other side. So they will just not unpack it. They will not use it at all. If there was Kamon on the other side and for some reason it couldn't understand the message, I need to double check this, but what would happen is that it will log an error saying I couldn't unpack the context, blah, 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 but execution should continue as usual.
But the AOP instrumentation, for example, when they move things around, that would then not match.
I'm not sure.
Aspect J?
When we move from aspect J to Canela, for example, you have aspect J here and Canela over there.
That would be another thing, but I mean, I understood it that you like have the point cards around some methods and so on, and probably when they rename things or so,
Yeah,
it will fail, right?
when they rename things, it breaks, yes. Yeah, that's something that we have to deal with on every release. Every time we instrument something, we try to find points that seem sort of stable. Points that you think like, well, if they change this, they will probably have to make some major changes on the framework itself. So when we find these points that seem kind of stable, we try to aim instrumentation at those points so that these have the most highly likelihood of working with further minor releases, because most of the time we hook on internal APIs, and most of the time they stay stable between minor releases. Most of the time we have seen issues where on major version upgrades of the libraries. It's a pain to do it, to keep track of these things, to be updating, because every time you do this, it's not as simple as, oh yeah, I changed method name and it just works. It means you have to come here and understand what they changed, why did they change it, and how does that affect the instrumentation. And once you understand all of this, then you are safe to say, oh, so I should move this instrumentation over there.
So do you think it's safe when using Kamon to perform Akka minor upgrades, or
Usually it is.
or
yeah.
should you check back on some Kamon page where you report compatibility?
From experience, it works. It most of the time works. The biggest problem we had with Akka upgrades was from 2.4 to 2.5, the way certain system messages were being handled was not consistent with how it was before, and it was very subtle to figure out how these things were failing. There were some race conditions that were really weird because of how the old instrumentation was done, and it was working with 2.4 but not with 2.5. We solved it, and after that all these minor Akka releases are working. Like, if you are in doubt, just let us know. Like, we should be testing this with every single minor version of Akka. Run all the tests with it and say, hey, new version released, the current module works because all the tests are passing.
Focusing on the Scala version or both versions, Java and Scala?
For us, it's the same. Like, the Java API is made on top of the Scala API, and we hook to what is underneath that. So it doesn't matter how you use it.
Mm-hmm.
Anyone else wants to, like, say anything about tracing or metrics or?
So with the tracing, what is the idea to store then traces for all the transactions going through the system, or you would selectively activate that for cases when you need it?
Well, by default, what happens in most systems is there is sampling, and there is a probability of a trace being sampled. So since at the edge of your system, you take a decision, like a request came, what am I going to do with this? Random number, oh yeah, I'm going to sample this. And then every other span that is related to it will be captured and sent to the tracing system. If the decision is not to sample, then none of the related spans will go. Now, there are a lot of conversations on how to make this smarter, because if you do this, you could end up with a lot of traces that you just don't care about. You need to have, on one side, more sophisticated samplers. Like if you have a health check, do you really want to trace the health check? Like it doesn't bring you any actual value to trace those requests, and maybe there is an actual business transaction that is happening that you want to trace, and turns out it was not for that, but just for this. There is a paper that is going to come out in a couple weeks from these guys at Brown University. They did a presentation in the distributed tracing workshop about capturing interesting traces. So they developed some sort of algorithm that gives certain score to each trace and allows you to identify which traces are different from each other, or which traces are interesting, so that maybe you can capture all the data or a good part of all the traces, and then you take this information, you analyze it, and you say, this one is interesting, and everything else you just drop. So it seems to be a more common topic in the tracing ecosystem, like people are talking more and more about it. So I think the implementers are going to move towards having some place where you aggregate all the data from all the traces. Like you basically sample everything, you capture everything, you aggregate it somehow, you analyze it, you decide what is important and what is not, and then you keep the important ones and drop everything else. It seems like that's where things are going, but right now the common approach is just sampling. There is this company called Lightstep. It's a company by the same guys from Open Tracing, and I think they do this. I think they get every single span, they analyze it, and then they keep the interesting ones. I don't know if anyone else is doing that. This is obviously something we want to do, and we heard of several people saying, okay, yeah, we also want to do that, but
What are the major use cases so far for distributed tracing?
well, when you have distributed, no. Actually, the use case would be more of a debugging scenario.
So, I mean, when we were thinking about introducing open tracing in the past, our idea was we had messages going through 25 systems. And every time we got an issue reported, someone had to dig through the logs of 25 systems and gather metrics and data out of it, and therefore our idea was to assign a unique identifier through all of the systems and put all of the spans, have all of the spans of one transaction through all of the systems. Is this a standard thing people are looking for, or because with sampling you don't get it, because if you want to do it on a user request, if someone complains and says, I have a problem with my event, and you're doing sampling, you can't be sure that you can answer.
But sampling is a decision that you do. So usually in all tracing systems, sampling is something that you can configure and you can enable. Tracing every single request has a cost, both in performance and in resources of the tracing system where you actually store this. And it might mean you need a Cassandra cluster for this, or you pay more to your SaaS solution that is doing tracing for you. So there is a cost associated to this. If you want to pay it, there is nothing saying you shouldn't trace 100% of transactions. You can do it. It's just going to be expensive to do so. So it's your decision. A lot of people want to do this kind of things because, like, when there is something interesting that you need to find, like, finding things in the logs could be complicated. If you have just some request ID that you could throw into the tracing system and get the full picture of what happened, that is insanely valuable. So if that brings business value to your debugging procedure, maybe it makes sense for you to spend the resources necessary for this thing to happen. Nobody says that you shouldn't do it. It's just like it's expensive, and you should figure out whether you can cover the costs for that. And also, I tend to see tracing as something that you would use for the debugging experience. So one thing is monitoring. You're not monitoring traces. You're monitoring metrics. Like, how is this indicator here? Is it beyond or not what I want it to be? And then when something is wrong and you need to figure out what is wrong, that is when traces become very important, because seeing the whole picture of one particular request, like if you have a picture of one that you know had a high latency and you see where these bars are bigger, like it's just a visual thing. You just see the trace and you know this is the problem.
I think you remember that Jaeger or Zipkin also has local agents. Jaeger or Zipkin, I think, has agents running directly on the host where the application runs. So I think that it's easier to just send all data over there to the agent, so that you, if I remember correct, can also later decide, okay, this was an error, or this was a slow request, I want to trace this, and then it's really collected from everywhere.
Yeah. As far as I know, none of them has that. Zipkin definitely doesn't have it. I don't know if maybe Jaeger got something like that lately, but I think they don't have that. Like, it would be very nice if they had it, but as far as I understand, they don't have these features.
Okay.
Yeah. Yep.
Lagom framework use Akka cluster sharding.
Mm-hmm.
So you have an Akka cluster, and for each entity,
Mm-hmm.
ID1, ID2, this runs on this node, ID1 runs on node A, ID2 runs on node B.
Mm-hmm.
You have no control, yeah? It's scalable.
Yep.
So when I need a good metric, the average mailbox size for all the
For all the entities.
actors.
Mm-hmm.
So I collect from each node the metrics.
Mm-hmm.
I need an average. You saw? I need the raw data.
Mm-hmm.
So I have to tag for every entity ID,
Well,
and I get a tag with a high cardinality.
yeah, that's
The
exactly
problem-
something that you shouldn't do. Like, you can do it for tracing. In tracing, it doesn't matter.
Okay.
Yeah.
Our metric?
But in metrics, no. Usually, you don't want to have too many time series involved in a query. Like, for example, Prometheus can handle millions of time series in one single instance. But it doesn't play well when you want to query something that involves more than 2, 3, 4,000 time series. So if you want to see, give me if you do this and you have metrics for each of them, and you want to say, I want to have a list of all what is the maximum mailbox size of all of these things. If you have more than 2,000 time series of that, you're probably going to overwhelm the Prometheus server. And in all metrics system out there, The biggest problem is cardinality. You can have many different metrics, but you never put more than 2,000-3,000 metrics on the same query because it's going to be slow. Or maybe even just time out and break or like just not succeed. So when you have these situations where you want to have IDs, well, you can have it in the trace, but you should definitely not have any metrics because you're going to break something.
How does cluster sharding metrics actually look like in Kamino?
Actually,
Do you have access to a cluster?
we are not using cluster sharding at the moment. And there is a dashboard for cluster sharding. There is instrumentation in Kamon for cluster sharding. But to be completely honest, I cannot tell you now out of my head the exact metrics that are being collected. Okay, I can follow up on that and drop a message on the Meetup comments section. Like, just write the documentation, put it on the Kamon website, and then link to that so that you can know exactly what you would be getting at the moment. I really don't remember.
That would be an important point.
Sorry, what?
That would be an important point.
Yeah, yeah.
We just finished our cluster sharding implementation. Next 2 weeks and then we can wait.
Yeah, actually,
that's realistic.
Yeah, but coming back to the tracing, so that you can also put some logic in the code to activate the tracing just for specific transactions you are looking for.
Can we add a custom tracing designer class? Yes.
sampler.
Was there something like that?
No, currently you can't.
So like in our use case, if we want to trace one specific customer.
Oh, no, wait.
Put some custom logic in the work just.
No, actually, you can. I think you can now. I think I need to check the code in Kamon. Currently, there was this always, never, or probability.
Mm-hmm.
And now the sampler API, the only information you get with the sampler is the operation name. So that's the only information you have to decide whether you will sample this or not. So it might not be enough for you to decide, but this is something that came up this week. Like, sometimes at the point you take the decision, you really don't know whether you want to do this or not. Like when the Kamon instrumentation kicks in, it's before your code runs. And if you're doing some random thing, this is fine. But if you want to use some business information to decide, then we're basically not allowing you to do that. But that is an important use case. So we should find a way in which the instrumentation could maybe delay the decision and allow the user code to decide how to proceed or how to wait in the available information to decide whether to trace or not. So that came up and we're taking it into account, but currently you cannot do anything about it.
Because at the moment that we would need to enable basically tracing of all the stuff and then throwing it away quickly, what we don't want to.
The question is, how often do you need really customer-specific tracing?
You can ask Rolando every day.
I mean, but that's again this debugging stuff. Like, do I want logs and do I want to see for this one request, for this one user, I want all the events of our system, or do I really want like performance tracing? That's, I mean, okay, it was slow, but is that why the customer asks so often, or is it because we were sending some weird answer?
Well,
Yeah, probably the customer
Only to this
complaining
one.
because the functionality was not
And
as expected, for example.
exactly, and I think you don't see the functionality so clear in a trace. You see it better in a log, I guess.
well,
So we go back to tailing log.
yeah.
We have one
Yeah, we
filter
have-
to apply.
But that's a good thing about having tracing and logging working together.
Okay.
which is that the tracer will make sure that you have a consistent ID that gets propagated across all your nodes. So if you know the trace ID or some request ID, let's say you have a trace ID and you also have some request ID or something that people on the other side can tell you, you know what, request 123 failed. And if the tracer and your instrumentation made sure that this 123 was propagated everywhere and it was included in the logs, then you can just grab the logs for this 123 and you will get the picture of what happened. The complicated part is making sure that 123 is everywhere where it has to be. And the tracer makes that a lot easier for you. So I don't think that there's anything wrong with grabbing the logs to debug an issue. You shouldn't be doing that to monitor the status of your system. So logs for debugging, that's totally fine. I don't see any problem with that.
So I have a question, maybe I missed it, but where is the traces is being stored?
Sorry?
Where are the traces being stored, and which database?
It depends. If you're using Zipkin, it has Cassandra, I think Elasticsearch, and MySQL.
You will just push the traces to Zipkin or J or whatever.
Yeah, like in the case of Zipkin, you push it to the Zipkin UI. It's basically, API. It's basically a Spring Boot application, reads all these things, blah, 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 and then stores in some storage backend. That can be Cassandra, can be MySQL, can be Elasticsearch, I think. And if you just want to play with it, and you can start a Zipkin container, it has an in-memory storage, so as long as the container is up, it will work. So if you want to just play around with the idea, just start the Docker, send the data there, and start seeing what is there. Also, Jagger has a in-memory storage that makes it super easy to try out, and we even run it in production for some time when we were testing these modules. We just got it running there every now and then. We restarted because they would crash out of memory error and things. So
you have a special plugin, SBT plugin for Play.
yeah,
Because the dev mode and the reloader.
yeah.
Lagom has a special plugin and has a quite different reloader as Play.
Yeah, yeah.
Do you plan a fork from the Lagom?
Well, here's the thing.
Because I love this dev mode. It's a big feature. And
Yeah.
I've tried your framework yesterday and
Mhm.
the Play plugin doesn't work. Because
Yeah.
the Lagom plugin is quite different.
Not only is different, it's harder to instrument. To instrument in the way we do. You can still start SBT with the Aspect JWeaver, and it will work. But you need to remember this when you are starting SBT.
Yeah.
I remember running a Lagom SBT with instrumentation, and it worked. But what we wanted to happen is if you have SVT, you add this plugin and it just works. And even with the Play one, we had to copy paste code. Like we had 20 lines of code for the plugin in the previous version for Play 2.5, and then in Play 2.6 they changed certain things, blah, 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 and we had to copy paste 3 files of code to make this thing work. And then someone came asking for the Lagom one, and well, I thought this was like the Play dev mode, and it's like they copy pasted the Play code and the Play dev mode into the Lagom dev mode, and then they move it around and change this and change that and change the other. So it was like another little universe. So far, only one person asked for this. So we did the research to have an idea of how much would it take us to get into this. But we didn't do it because it was just one person. If you are interested in, if you get into like really using Kamon, you can work around it by starting with the agent, start SBT with the agent, And if you keep nagging, then we will also do it. At least there is a workaround. Like if it was something that you cannot do, like there is no way to work it around, then it would put more pressure on us to do it. But for example, there's this guy from eBay who was trying out Kamon and trying out specifically the play instrumentation, and he found a lot of corner cases on the SVT plugin. Like if you want to put your own configuration files and some specific JVM properties for the typesafe config library, then things would break. It would not take the proper configuration. Things related to the class path, like the class loaders in play have a weird hierarchy. So all those things are there and we need to fix. And then once that is fixed here, then we would also need to fix that when we do the lagom thing. So that is something that is high on our list, but only for play, not for lagom. I'm not gonna lie to you, say, oh yeah, we're gonna do it as soon as possible. Nah, it's most likely not gonna happen soon.
We just discussed putting things from the context into the logs via Kamon logback.
Mm-hmm.
I've seen some commits regarding MDC that things can be propagated from the context to the message diagnostic context, or however it was called, of logback. So would that copy all the context information into logback MDC, or only like predefined ones? Because like when we use JSON logging, then I think I can only access this MDC and not this conversion rule, how we use it currently logback, or am I missing something?
Yeah, actually, I think now it will try to copy everything from the context there. Like it has a special rule for the span ID and the trace ID, and all other things will try to do like a toString of whatever is there on the other side. We are encouraging people not to use the MDC. But if you definitely have to, and you have to copy from the Kamon context to the MDC, yeah, there is this. Although we didn't release a version with that yet. It is in the repository, but it's not released yet. So if you want to try it out before we release it, just in case there is some problem, that would be nice.
Do you see an alternative when I use logback's JSON layout or this log/logback encoder? Just really to get JSON logging.
Honestly, I didn't get into it. I don't know if there is an alternative.
Good. I didn't find anything else than MDC.
Yeah, I really don't know. Good. Anything else, guys? Good. I'm going to.
You can still stay around.
Yeah. I just want to grab a sandwich.
Sure. So I would say let's thank Ivan. Thanks for being here.
Thanks to you guys for coming here, listening to this endless monologue on monitoring.
Enjoy.